My dear people, here we have a very simple problem. Yeah, there is a pipe of constantly increasing diameter. The velocity with which the fluid is flowing in is 5 meters per second, and the entry diameter we have been given is 20 centimeter. We have been asked to find out what would be the exit velocity of the fluid if the the exit radius is 40 centimeter. You see, they are trying to confuse you. Yeah, so that's why I have written the given in standard form. C1 velocity 1 is 5 meters per second, diameter 1 is 20 centimeter, written in standard form meter. We know the radius 2, so I have written it in diameter equals 80 into 10 power minus 2 meter. Don't just take it as radius. Yeah, or if you want, you can convert section 1 into radius as well. We have been asked to find what is c2, otherwise the velocity with which the fluid will flow out. Well, even before we start the problem, okay, even before we start anything, you tell me, do you think C2 will be a greater or will it be a smaller number than 5 meters per second? What do you think? Hmm? What did who said greater? Oh yeah, yeah. Okay, okay. That was a joke, was it? Okay. C2 will be lower than C1 because of the increase in the cross-sectional area. Okay. So, my dear people, we know that the mass flow rate is always the same. So m dot 1, the mass flow rate in section 1 will equal to m dot 2. This is continuity equation for us, is it not? Yeah, the mass flow rate is always the same. Mass flow rate equation is nothing but m dot is rho a c. So I have written it as m dot 1 is rho 1 a1 c1 equals m dot 2 is rho 2 a2 c2. This is what I have written. Since the density of the liquid entering and exiting is the same, so I've just cancelled out the density. So we have a1 c1 equals a2 c2. Yeah. um since this is a the cross sectional area is circular, the area of a circle is pi by 4 d1 square times c1 equals, for the second cross sectional area, pi by 4 d2 square times c2. C2 is what we need, so I'm just going to rearrange the equation. Well, but before that, pi by 4 is a common term in both these things, so let's cancel that. There we go. So now let us rearrange the equation to find C2. Yeah, this goes to the other side of the equation and becomes divided by. Now, if you think of it, we know D1, we know C1, we also know D2. All that we do is we substitute in the equation and we get the answer as 0.313 meters per second. So, do you see? I told you that C2 will be smaller than C1. Yeah, look at this. C2, the velocity with which the water will come out or the fluid will come out is 0.313 meters per second, whereas it enters at 5 meters per second. Yeah. Uh-huh. Okay, you know what? Our problem actually stops here. But then I thought, why don't we also find the volumetric flow rate and the mass flow rate of the liquid? Shall we do that? Yeah. Otherwise, what is the volume of liquid that is flowing in and out? Because volumetric flow rate should also be the same. Yeah. Okay, so let us find the volumetric flow rate. Do you all remember what is the equation for volumetric flow rate? Hmm? It is nothing but area times the velocity. Yeah, of the, I'm just finding out the volumetric flow rate at 1. It should be equal to volumetric flow rate at 2 anyway. So area is pi by 4 times the diameter 1. Diameter 1 is, we know, is 20 centimeter. Yeah, so I've written it as 20 into 10 power minus 2 square times 5, and the answer I get after putting it into calculator is 157.1 into 10 power minus 3 meter cubes per second. That is the unit, don't forget the unit. Yeah, okay, now the last thing is mass flow rate. Mass flow rate, do you all remember the equation for it? It is very simple. Mass flow rate is nothing but the density of the fluid times the volumetric flow rate. Look at this, density rho times the volumetric flow rate. Oh no, but then we do not know what is the density of the fluid, do we? So I will assume that the fluid is water, and the density of water is 1,000. Yeah, so all that I do is I just substitute the numbers. 1,000 is the density times the volumetric flow rate, put it in the calculator, and then I get the answer. It is as simple as that. Yeah, if you have got the same answer as well, well done.